south and back up to north again, myself in the plane. I reckon that
Yeah. You
might
reckon it's the ground bit underneath?
yeah, and
coming
I
back.
reckon I reckon I could tell if I'm turning left or right or doing any sort of dodgy maneuvers, doing quickly going to Antarctica and then quickly doing a quick right hand turn and going somewhere else. I reckon I'd have the nous about me to be able to work that out. But I reckon if I personally was in a plane and then could circumnavigate it all the way around, I reckon that.
Especially if you felt like you were upside down at one point, right?
Yeah, well, yeah.
No, that's
Exactly.
far out. It's far out because you're never going to have a plan and do it. But it's much more reasonable that you've actually found a real solution that would convince you.
Yeah.
Yeah, but your vestibular system acts like a gyroscope, and you would know if you're going around a ball or not. So the path could make it seem like you're going around it, but it's just a dip down into Antarctica over a certain area and then up to the other side, and it doesn't prove that you're on a ball necessarily. It's just a path.
Yeah. If Bandy, if on a flat plane you followed the equator just above the surface, would you actually think you'd know if you were turning left or right, which way you went the whole time? Like if you just followed magnetic west or east?
I reckon if I was to follow a heading, yep, and I was to look at my whatever you call them, the little altitude meter, whatever you call that. There is a word for it. I reckon I'd be able to nut it out. I think I would. Yep.
Fair enough.
Yep. If I'm being honest. Yep. Now, as Dawn said, the chances of me doing that are next to zero. Right? I'm never going to get that opportunity to do it. But that would be one of those things that if I haven't experienced it, it's not real. Like I had this conversation with Bob, the other day, talking about China, and I threw in his face, well, does China exist? Well, he hasn't been there. He wouldn't even say the word China. He just called it a country, right? Wouldn't even say the word China. Which, okay, then you haven't been there, you haven't experienced it. It's been a bit like a Slick James type of way of logic.
I don't have no beliefs.
Exactly. I only have experiences. So if I could get one of those experiences for myself, yeah, I reckon that would go a long way. Definitely, that would go a long way.
Let's say, Bansor, if you had the money and you had a plan and you could learn to fly that, you wouldn't only do it once, would you? You could do it a few times and make sure you're not going round left.
Well, I suppose you could, yeah. I suppose you could do it, multiple times if you had that kind of.
You sort of confirm.
Kind of money.
Like this could be a delusion. It could be a hologram parallel Earth, like Arwen thought, and I could have been portaled round. But then if you keep doing it and you manage to be awake through the journey, and eventually you'll realize, yeah, I'm going round some object. It can't be a 2D plane.
Yeah, but I think I've got more chance in flying over Antarctica and flying into undiscovered lands than I have in going all the way around the globe.
Yeah, so you don't think it's likely, even if you could do it.
Sorry, what was that?
You don't think it's likely you would ever discover a globe, even if you could try?
No, I don't think it. No, I don't think it's possible at all. No. Sorry, Dave. Go, man.
Oh, go ahead. I didn't mean to cut you off.
No, I was just answering Dawn. No, I don't think it's likely at all that I would discover a globe, but I've got more chance in discovering undiscovered lands and alien peoples.
New Schwab
Yeah, which would
Do
be
you,
pretty cool.
do you understand what my gifts are saying there, Bansal, though? I mean, do you see what I'm saying? With if you had a jet that could go 1,200 miles per hour, right,
Mm-hmm.
and you had 40,000 pounds of thrust hovering, that could get out of sync with the Earth, right? You understand that
Yeah.
they can't claim that the plane, no matter what it does, is always going to have the illusion of a stationary Earth. It's a complete contradiction. It ends the conversation, in my opinion. In fact, this one can fly faster than the rotation of the Earth, right? So it could go in the direction of the opposite direction, right? And go 1,200 miles per hour, and then stop and wait for the globe to catch up to it.
Mm-hmm.
And then if the globe doesn't spin to catch up to it while it's hovering, then the Earth's not spinning.
No,
Game over.
it's a misunderstanding. But I
Okay,
will
explain it to us.
I will give you that with a camera, you might be able to record some drift somehow.
You should be able to, right?
I think so.
But why is that a misunderstanding? What I said?
Because you're expecting to record all the drift really easily, which is absurd.
No, I said no, but the scenario I just said, where it could fly faster than the rotation, and then stop and wait for the rotation.
Yeah, that's the
catch up.
absurd bit. You're treating an aircraft like a spacecraft that can hover in space. So that's you believing in space sort of thing for the concept.
No, because planes are out of no matter what, any airplane would be in its own reference frame. There's an inertial and a non-inertial reference frame.
How do you know that?
That's just the Globers admit to that.
No.
That's why there is a Coriolis effect. Because the Globers claim that the projectiles have a Coriolis displacement, right? So that if you're shooting north to south, the reason for it, that means that the Earth is turning below the projectile. So once something's in the air, the Earth is an independently moving reference frame. That's just the rules of physics. It's not a flat Earth opinion or misunderstanding. It's just the rules of physics.
Spinning with Earth, around Earth in the atmosphere.
You haven't looked into this, obviously, but there actually are two reference frames.
Gases are unbonded, so how is that atmosphere spinning with the Earth?
How?
Yeah, they're not sticky.
That's a good question about Earth. How is the atmosphere spinning with Earth? Gravity pulls it round. The spin pulls it round.
Gas is
friction.
Gravity.
It's friction.
Yeah, it's friction that pulls it.
I'm actually happy with optical measurements. I think there are hundreds and thousands of them taken every single day.
Yeah, that's good.
And I think it can quite easily measured myself within the tolerance of accuracy.
Oh, therefore it's a ball, Bandy.
No, I'm not talking about you. I'm not talking about bullshit spherical excess over 80 kilometers. I'm not talking about that at all. No, not talking about that at all.
Well, if you're talking about verified things physically, then yeah, of course, optical measurements are very accurate.
I'm not talking about an optical measurement over 80, 100 mile. I'm not talking about that at all.
No, well, that can't be verified. But an optical measurement over 7 inches or 20 feet, fucking oath, that could be physically verified to be accurate.
What a weird set of logic you have.
Just got to understand there's a calibration tool. To calibrate a tool to make sure it's precise, it needs to be verified that it can do the job. You can't then extrapolate that tool and calibrate it for a certain thing out to infinity, assume it's still accurate. It would need to be verified as such.
I'm not talking about extrapolating it over infinity.
I was talking to Dawn.
Oh, okay.
Yeah, well, tell us what you're talking about.
No, I'm just talking about doing a leapfrog measurement from one point to another, moving your datum point. It's done every single day with a very high degree of accuracy, well within the 8 inches per mile squared, well within it.
But if we were actually spinning, not only would the thing that I'm talking about work, there'd be all kinds of ways to measure our spin. Just because they can argue that we wouldn't be able to feel it, there'd be so many ways that we would know we're spinning. So the measurements of curvature are like second to that in my.
Well, that's very true. All you gotta do is tie like what, a rope, maybe 100 feet to a balloon, and let it sit there. If it doesn't drift in the direction, the opposite direction of the spin, then what's going on?
Hey, how you doing?
How's it going, Bandsaw?
Yeah, good, buddy. Good, my friend.
Yeah, that's why I use the jet in this example, because if they want to claim conservation of momentum, which is a law of physics, it doesn't work the way they hope it works. They exaggerate it so that they can just claim that it lasts forever or whatever else. But just because that is part of the law of physics, you can say, well, this jet flies faster than the spin, has 40,000 pounds of thrust. It can hover in midair, and it can fly over different tangential speeds. So this conservation of momentum, then you have to claim that somehow the winds and the atmosphere have forced this powerful jet to slow down or speed up to match the tangential speed to maintain the illusion of no Earth movement ever. Not any kind of hint of Earth movement under a jet that goes wherever it wants. Flies in a straight line, flies backwards, does circles, goes into the jet stream, out of the jet stream. But somehow, when it pops back into a different tangential speed than it started out as, it's always going to have the illusion of a completely stationary Earth. No way.
Yeah.
Not possible.
Right.
They have to claim magic winds.
Yeah, magic gases actually. Yeah, winds. Yep. Right.
Magic.
I still reckon shooting a cannon up, perfectly plumb, a heavy cannon, perfectly plumb as far as you can set a charge. I still reckon that would be the best, because if it doesn't land back in the barrel, there's fucking something, and if it's rotating, it should obviously land in a certain position versus fucking where it goes. Because like you're talking with the jet, the cannon can actually accelerate up at such a speed, it should actually overwhelm observation momentum
No,
pretty much.
no.
Yeah, but
Then you,
they'll say that it does. But they have that one video where the ping pong ball pops out of the train as it's going, and it goes right back into the cup, and that it's impressive example of conservation of momentum. But it doesn't apply in the same way. Yeah, as soon as it went up, in fact, high enough, it's in a greater circle, so it's not even at the surface of the Earth, which is a different diameter or circumference,
exactly my point.
diameter. That is, yeah. So it would definitely do that. It should do that. But their claim again is totally contradictory to science, and they stick with it because they have to.
did it land back in his barrels on?
Yeah, it landed right next to him almost.
Really?
They hurried up, ran right underneath their truck or their car or whatever, and bam, you can hear it hit back down on the ground. It took about 1 point something seconds or something around there. I can't remember. It was a while ago to watch it.
Okay.
But it didn't like drift
How
off.
high did it go?
I don't know if you can calculate the seconds. So probably you may get something feet per second. You're gonna have to calculate it. You'll probably get it. How high? Maybe.
Interesting.
Oh, so hang on. How did he know that was straight up?
No, he
doesn't even
shot
look
it.
straight.
No, he didn't shoot it like that. That's just the thumbnail.
Oh, good. You'd want to get like a theodolite or something, have it fucking like a plum. Or...
Did you have a jig or something on?
No, he just held it up. It's been a while since it.
Yeah, I'm scrolling through it now, actually.
Yeah, see, with a cannon, I'd hang a plum right down the center of the barrel and make sure it's fucking dinky die, fucking pointing straight up. Boom.
And what about the rotation of the ball and all that sort of stuff, whacking it off?
Well, I wouldn't put any rifling in the barrel, and given the mass, it wouldn't rotate.
Maybe.
Not to the point that you'd get that Hutchison effect.
Yeah.
You know
It's
what's so
weird, though.
telling? Last thing
Go
I'll
ahead.
say about, I gotta go, but the last thing I'll say about that jet idea is it's interesting when you propose this idea to a baller, how confident they are that the jet will never be able to see anything but a stationary Earth. You know, like you could say, look, it could fly, you know, wherever it wants, do whatever it wants, and it's always going to have the illusion of a stationary Earth. How could you be so sure? I mean, it's
Because
pretty
yeah,
magical, right?
it's the same reason they'll say the ball will always land back in its hole in the cannon and all that sort of shit.
Yeah, yeah, exactly. All right, good night, guys.
Like I've
As the resident caller, what do we
Right.
say?
sorry.
As the resident baller, what would we say?
Okay, so did you see my 2 gifts that I put in the live stream?
Who are you?
New perspective. There's 2 gifts with a jet, the F-35B that has 40,000 pounds of thrust, can hover in midair with 40,000 pounds of thrust. I don't know if I talked to you. You might have been somebody I talked to about this at some point. And it flies faster than they say that the Earth rotates. It goes like 1,200 miles per hour. So the idea is that if this jet could fly a dead reckoning north or south, and refuse any kind of adjustment that the plane is trying to make, you know, and just would the Earth rotate independently west to east underneath it, and it would be able to put cameras underneath it as it flies over different tangential speeds, to fly around the globe, do circles, go into the jet stream, out of the jet stream, just to get out of sync, so that it doesn't always have the illusion of a stationary Earth relative to its own speed. Is that possible, you think? With some cameras underneath this, you could prove the Earth spins.
I think that based on the fact that it's flying in air, no, because you're always going to be making more adjustments based upon the atmosphere that you're flying through. So you're kind of screwed.
So that they would force the atmosphere would force this plane to always be within the illusion of a completely stationary Earth.
I wouldn't say that, but okay.
Well, you said it, and then you said okay as if you were saying it. Why couldn't this jet
we
show
could take
that
something
the Earth spin?
up really high. We could put something up really high, fly it over the Earth, and we'll see that it does spin from underneath it. And satellites.
Yeah, the satellite images of a spinning Earth would be nice by now. Yeah, that would be nice.
You have hundreds.
Oh, really? Let's show.
Post
one.
Of them.
Post one for us. Let's see.
MRA8. The Apollo.
I'll just post what you think looks real. Just post the one you really believe looks real.
I just told you.
But wait, do you accept that the plane?
Why do you want me to?
Hold on, wait. Do you accept that? You accept that the plane's in its own reference frame?
Actually, what I said is satellites we could use, because the airplane is stuck in the atmosphere. It kind of is bound to that. So anything that happens to it is going to be inconclusive regarding the motion of the Earth. Not that it'll show a stationary Earth, that it will be inconclusive based upon your standards of evidence.
But then if we're using like a projectile, right? The reason that a projectile might be off course is because the Earth is spins below the projectile, right?
Sure.
Okay, so that same evidence, that same kind of application doesn't go for a plane. It's not the same.
No, you would never accept the evidence.
No, I'm not asking what I accept. I'm saying you think that a projectile and a plane are totally different. They're not.
Okay, that's okay. You didn't want to hear. That's fine. You want to just talk.
Well, no. If you're starting out with a claim about what I'd accept, I'm just making sure you know that. Run away.
That's tough.
Yeah, see, he's so sure that the plane could never see anything but a stationary Earth. Yet a bullet totally would see it if it had cameras. Anyway, I got to go to bed, guys. Sorry, Moyak, I didn't mean to cut you off.
All right, Dave. Catch you later, man.
The fuck you didn't.
So with the with the example the ballers give of the guy bouncing on the trampoline in the back of a truck, getting towed along, he just bounces up and down. It doesn't fly off the back or anything like that. If the person
Right.
bounced on the trampoline and didn't fall back to the trampoline and somehow could just stay in that position, is it actually like honestly suggested that that person would just continue going along in that position above the trampoline because they're in lockstep with the atmosphere and the atmosphere is in lockstep with the fucking, or is it appreciated that that person would eventually drift out of sync with the trampoline?
Given enough time, the mass of the air hitting him going slower than the trampoline would eventually drag him back off of it. Like if you hovered a balloon in there, it would float off.
But say the wind is like going in the same direction as the car and the same speed as the car, then there would be no reason for him to slow down.
Sure. If it was a sealed system.
Hang on.
What do you mean by sealed?
When he lands
I mean,
on the trampoline, there's a physical connection, and he is then given more force, more energy, right? And then he bounces up, right? Bounces up, and then he's carried along for a bit. But because he falls down so quickly, we don't actually get to see him drift back at all.
True.
But if he was to like pop up and stay there for a bit, we wouldn't, even in a sealed environment, he's not connected to the ground. And
So
the air
if he-
is not a solid connection. So it
So
can't be
if
inputting
he-
the same force at all as the ground
No,
does.
So if the wind is a certain speed and he's hovering
There's
up
no
there,
wind.
let's say
There's no wind. There is no wind.
there's
in this
always
system.
there's always a relative wind. If you're going
Okay,
forward,
but in this system, there's no wind.
if there's
In my
no
example,
wind,
there is no wind.
if there's no wind, what do you mean about? You're saying that measured from ground level, it is 0 miles per hour. It is stagnant. Is that what you're saying?
Yeah, the atmosphere is in lockstep. There is no wind. It's
Okay.
just moving with the earth.
Then yes, then he would slow down because drag is a thing.
I think you've described an airplane. I think what you've done is describe the hypersonic airplanes.
Okay, so
You can-
go
you
back
can
to the
float a
cannon.
balloon in
You
a
shoot a
hypersonic
cannon
airplane.
from
It's straight
plumb
like no other
with a
airplane.
heavy mass, and you shoot it up, and it's up in the air for long enough that it should drift away from the cannon before it lands.
Correct.
That is true.
Right, but you guys have all claimed that conservation of momentum will put the cannonball straight back into the barrel.
No. What do you mean by that?
Exactly what I just said.
That conservation of momentum doesn't say that it's going to land straight back into the barrel. What do you mean by that?
Well, exactly what I just said. It would go up and be carried along with the atmosphere.
Okay, go ahead.
Well, yeah, if the atmosphere is moving with the earth, yeah, it'll go back in.
Well, apparently it's Velcroed. So yeah,
pretty
it would
much.
apparently.
Sticky gases.
So what? So does it land in the barrel, guys, or does it land away from the barrel based on rotation?
If you
It
shoot it
doesn't
high
land
enough, it'll
away
miss the barrel.
based on. It doesn't land away based on or because of rotation. It lands away because you've expanded energy with the gunpowder that forces it with a speed out the other end. You still
No,
get.
no, hold on.
Okay, go ahead.
Stop. I mean, he's talking about the example where you they have a little tiny model train that shoots a ping pong ball straight up in the air while it's moving.
Oh, okay.
And it drops back in. And that, over a high enough distance, will, because of centrifugal force and radiuses and stuff like that, will deviate from the barrel given enough height.
Yeah. And that's actually the other way around from what he stated. If you shoot it high enough, and let's say you somehow manage to get it straight up, then it would fall away because of conservation of angular momentum. That would be the reason that it doesn't land back cannon.
Fantastic. So all the experiments where they shoot things up and it lands either back in the barrel or straight back down, how would you account for that on a rotating Earth?
Because it doesn't shoot high enough to where the deviation is noticeable enough to where it would fall out the barrel.
Of course.
You
Of
don't
you laugh.
understand
course. Not quite
gradual
high enough.
chain?
What, an
Do
extra
you not
meter? An
understand? Do
extra
you not
meter?
understand gradual chain? Is that not an
How high does
understandable
it need to
concept
go?
to you?
How
It's a
high do you
gradual.
think's high enough?
Have you ever heard of gradual change?
What do you reckon's the right height?
Well, 300 feet in the vacuum chamber drop tower seems to be, if I remember correctly, about 3 inches of deviation, or 3 centimeters. I can't remember if it was inches or centimeters.
Can you tell me
Um,
exactly what
Yeah.
amount of money a little becomes a lot? What exact amount of money makes a little become a lot? That's the question you're asking. You're asking about a gradual change,
No.
and you're telling me
You
what's the
said if
exact
it
moment.
gets shot
Oh,
up,
that's a straw man.
you said if it
It's
gets
not.
shot up, it would
Yeah.
land away from the cannon. I said, okay, if there's footage of these things landing back near the cannon, what would you say given we're on a rotating Earth? Then you said, oh, it wouldn't go up high enough or it didn't go up high enough. So I asked, how high is high enough? Because a minute ago you said on a rotating Earth, it would just land away from it without any caveat to being certain height.
no,
So
because he was
elaborate,
describing
please.
something different than you were describing. You weren't clear with your question, and he wasn't
Oh,
clear with
so
his answer.
no, you cleared my question up and he agreed with your clarification and then went on to describe what he did. You cleared it up perfectly fine.
Yo.
Then we came to agreement.
Hello? Yeah. Yep. Testing. Yeah.
All right, you can
So
stop
we
now.
can figure it out right here, right now. We can figure it out. Yeah.
All right, I'm turning whoever this is down because they're just interrupting with no purpose.
Well, we could figure it out, right?
Could. Some of us could. I'm not sure about everyone, but yeah.
Yes, the reason
Well, if
that
you
little
hang a
tiny
plum
choo-choo
straight
train
down the
works
barrel,
nicely.
It's because
So
there's
two
no
of you were
mass in the
talking at
fucking.
the same time. What did you say, Mark? Two people were talking at the same time.
Oh, okay. Yeah, the reason that the little choo-choo train works is because the elevation that's shooting up is only about 3 inches. So any what do you call it? Angular momentum differences because of the radius that it's expanding to fall into the nanometer category. So it will fall back in. Now, if you shot it up 300 feet from that in a moving train on a vacuum, it would miss by 3 centimeters, approximately, because the force is very minute.
Why bounce someone behind a truck on a trampoline? Claim that it means anything.
It demonstrates conservation of momentum.
Yeah, because the friction of the trampoline.
So realize here that the trampoline example is showing conservation of momentum, while I told you that the cannonball would fall behind over a big distance because of conservation of angular momentum. Do you know that there are two different momentums, angular momentum and linear momentum?
Well, there's angular with the person in the truck as well, because aren't we on a ball?
Yeah, but there.
Right.
So what I'm saying is, when you're shooting something really high up, you do not get conservation of linear momentum. You shoot something a small amount, you get essentially just conservation of momentum.
So are you saying the gases are not in lockstep with the Earth?
On average, yes. But of course, there are deviations like wind and high pressure, low pressure, and all of these things. But on average, yes, it is it is the same.
So you would have conservation of momentum with the cannon. You'll still have that.
So
So it should land back into the barrel.
So the reason why you only have the conservation of angular momentum and not conservation of momentum or linear momentum is because of gravity. Because when you have a force in any direction, it will affect the momentum. When it's not a big deviation in height, like on the trampoline example, then linear momentum is conserved because that force is happening over such a small difference with such a small change in angle, in direction, that you can just disregard the angular momentum. You can just say it's just conservation of linear momentum. When you're doing it over a large distance, well, now the linear momentum angle, because the force has changed angle, which is the angle of down, you have actually changed the linear momentum. Only the angular momentum is conserved.
Okay, so what height does the cannon need to go for this to impact it?
Okay, now the answer I can give you is that it's a gradual change. So if you gave me an amount of change that needs to go, let's say it needs to deviate from the cannon by 20 centimeters, I can tell you what height that needs to be. If you give me the speed and so on, there's a lot of variables coming in here, which is why you can't just say, oh, it's a specific height. It's a height depending on how much deviation, how much speed, and all of these things. That's why it's not a yes or no answer or like a specific height answer.
Okay, so if let's just say I do it and it goes 300 meters and it lands back, like hits the cannon right next to the cannon, you'd obviously have to run a bunch of maths. No doubt that maths would come out to say, oh, yep, it was only high enough to land where it landed, therefore we're rotating.
No, we could predict it ahead of time.
Yeah, but ahead of time, you could tell me this cannon shoots this fast. I can tell you based on where we are how much it will deviate. It is a predictive measurement.
Well, don't you think this would be a very good experiment for ballers to do?
Sure.
Show
just let me get me cannon out me shed.
Well, it does beg the question, though. But it does beg the question, though. How will we test for the variable of this if it's the sky rotating, and if it has an effect on the cannonball? How will we test for that?
What do you mean the sky rotating?
Yeah, it has momentum itself, right? It's conservation of momentum. The sky moving, not the earth.
This is done in a vacuum, so it's the one that I'm thinking of is the drop tower. Demonstrates this wonderfully, and it's done in a vacuum, so the sky is eliminated, isn't it?
That would be a start, I would
say. Like a vertical drop.
Yeah, vertical.
Yeah.
I mean, what we can
do they do it two ways. They do a vertical drop just from the top. They do it just vertical drop from the top, and then there's another one where they double the value by shooting it up in the air, and then it's in free fall from the second it leaves the barrel until it touches the ground, so you can double the distance.
Yeah.
I forget if it's 150 and 150 to 300, or if it's 300 and 300 equals 600 feet. I can't remember what the measurements are.
So this is a big long tube, is it? A vacuum tube and something?
Yes.
Shut up.
Drop tower. I forget what the hell the name of it is. Dig around. Biggest vacuum drop tower or something like that.
Who verified that that tube indeed can plumb? Does it have a plumb hanging in?
Well, we assume, from the sake of dealing with these conversations, that it is true. If you want to go out there and verify that it is not true, then be more power to you. Find out that they've all been lying and this tower is leaning like the Leaning Tower of Pisa.
No, I simply asked, do they have a plum hanging next to it so that when people view this, they've got a reference. Go, oh yeah, look, there's a plum and there's the tube.
More power to you. If you don't believe in tests, that's fine.
Like
Then you go make yourself a drop down.
No, I
personally.
never said that.
Okay, so
Fuck.
we
I said I
personally
don't
are
believe
not.
in it.
We personally don't necessarily know what measure they use to make it plumb, but we assume that when you set up that big of a thing and you spend so much money doing such a thing, you do take the time to make sure it's plumb.
Yeah, that's fair enough, and I understand that. But like the the pendulum that fucking swings around, Foucault
Foucault?
pendulum. You
Yeah.
know, people don't expect that to have magnets in the fucking thing underneath it or on top of it, and special driving mechanism, and to be set up to operate a certain way. People don't expect that. They think it's just
Well,
a pendulum that gets swung, and
people who
the Earth turns
understand how
underneath
it
it.
works, people who understand how it works expect that.
Oh, fair enough. Fair enough.
But I
Yeah.
can understand that the
They should make
average
it.
person doesn't.
They
Yeah,
should
that's
make
fine.
it all clear, very clear. A plaque that's right out the front of it for people to stand there and go, "Oh yeah, cool. So it's driven by this, and there's a magnet here to keep deflecting it. Excellent.
There's no
Sounds
magnet
legitimate."
that deflects it. It's a magnet that keeps it going. The
Oh,
actual
that's handy.
precession is happening due to an external thing, which is the Earth's spin. At least that's our claimed reason for it. The magnet doesn't make it precess; it only makes it go back and forth. The precession seems to happen without any of the mechanisms creating precession. That is why it's a phenomenon, because none of the mechanisms you've
How long have you
installed
been in the flat Earth
actually make
community
it
that you don't know this?
Isn't the phenomena more that doesn't it stop doing what it does, like on a full moon or some shit?
That's
That's never been proven.
That's a claimed thing that it doesn't work on a full moon, or that it starts doing weird stuff on a full moon. It's never been perfectly replicated.
I think it's a claim thing that it actually does what you claim that it does in the first place. That's the claim.
The difference between the one claim and the other claim is that the claim that it works is, okay, we have like 50 of them installed all over the world and they all work without any problem. And then the one claim is that this one guy called Ale, which was a French guy, did this, and then people tried reproducing it. Some people seemed to get some sort of result, some people did not get any result, and it's just really up in the air. That's the difference between yours and mine. One is testable, repeatable, and has been done. The other one is testable, repeatable, but hasn't really been gotten any kind of result from it.
You're talking about the Foucault pendulum?
Yeah.
The one you don't have a second reference frame for, that you absolutely must have for Coriolis effect, that one?
Well, explain precession there, Mr. Okay. Go ahead, explain precession, Jeremy. Why is it precession? Whether it be one of these ones in a laboratory or whether it be one in a stairwell, they all precess exactly as predicted.
Even get to the precession, just because you have a prediction doesn't mean anything, first of all. And just because something works also doesn't mean anything. We've been through this. But in order to have a Coriolis effect, you're definitely going to need two reference frames.
Okay, so what what reference frame do you need for something to precess? Just saying, just two. That's not quite
In order
true.
to have Coriolis, you need the inertial and the non-inertial reference frame.
Okay, so the inertial one, or let's start with the non-inertial one. I'm thinking.
Jesus,
I just for a second mixed
Jeremy.
I don't want to hijack the whole thing, but I just wanted to ask if Moyak ever showed his globe thing with the triangles, the bandsaw. Did you show him that or no, Moyak? We were talking
the globe
about
thing
last night.
With the triangles, the spherical triangles, the videos and photos. Is that what you're talking about?
Yeah. Did bandsaw ask to see those, or?
I don't know if you see them.
I have a question y'all can ponder too that I've never gotten an answer for. He asked for the distance of the height that the cannonball would have to travel where it wouldn't come back into the barrel, but y'all said y'all can figure that out. But it seems like that would already be, that test has been done. It seems like that height would already be figured out. But anyway, at what height or altitude we'd be dealing with, would the atmosphere stop rotating? Good luck.
Love
Where
it,
would the
Rocky. I love
atmosphere
it.
stop rotating?
Yeah, does it go forever or does it stop at like where does it stop? That's a great question, Rocky. Great, absolutely love it.
Well, that would have to be 100 kilometers.
No.
Yeah, the carbon line.
No, the Kármán line is just an arbitrary distance chosen. It's not like that. That's where everything atmospheric stops happening.
Okay, so good answer. So where does it stop?
Again, just like before, it's a gradual thing. Now, when you say stop, what is stop?
Well,
Is
you're
it
saying it's
complete?
rotating, right?
Well, where it
If the
dissipates.
atmosphere is rotating, the higher it goes, the faster it has to go to keep that tangential speed, right? To conserve momentum of an object in it. So at what altitude does it slow down, or does it speed up, or does it stop rotating, or does it ever stop rotating? What's your theory on that?
So the place where it would stop rotating in quotation marks, would be when there's not enough air there to maintain essentially the interaction of spin. Where the interaction of the heat, as in the average kinetic of the molecules up there, wouldn't be on average moving in the same direction. They would
I
be
get
too
your answer.
chaotic.
Okay, so the higher you go up, the less dense the area is, the less rotation of that atmosphere you're going to have, correct?
Not less rotation, but rather the less you have, the more chaotic it can be. And at some point, the temperature takes over as the dominant movement, so to speak.
Sure, where's that at?
Well, it's again one of those questions where it is a gradual change. So first, we need to determine when is one thing, when has it changed?
What's your model? I mean, I'm just asking
what would you
what you're
call
claiming.
stopping, Rookie? If it's still moving with the Earth at 1 centimeter per century, generally speaking, is that stopped?
Yeah, wherever you can stop measuring it, maybe. I mean, you're saying you're measuring.
Well, I would say it'd be hard to measure 1 centimeter per century, so I don't know what would you accept. I mean,
Yeah, we heard you on that one, so you didn't need to interrupt me. But if the atmosphere is rotating with the Earth at whatever speed the Earth is going, the atmosphere has to be going a certain speed, right? Or would you call it something other than speed? I mean, the air is moving, right? That's what's conserving the momentum.
Like Velcro, man. Lockstep.
So
never said that.
in my mind, the higher you go up, the faster it would have to be spinning just to keep up. But if you're saying it's lagging behind or slowing down, do we measure that anywhere?
In the different layers, it does lag behind. I don't know when it happens past or up around the Kármán line. I don't know exactly what's happening to the speed, but generally speaking, it does tend to start lagging behind.
Okay, well, if it does start lagging behind, then in theory, right, and just common sense, it would have to almost stop or really slow down significantly enough where you could, 1,000 miles an hour to 1 mile an hour, you could, you'd have to be able to measure that, right? And if that guy's going to answer that the heat takes over, that's the first time I've ever heard that. Maybe he can maybe further explain that. Because thermal happens.
I'm trying to think what would you reference it to at that.
Anyway, anybody wants to carry on?
I don't know what you would reference it to and how you would measure it. Once you get to being just fucking random particles bouncing around up there, it's kind of going to be hard to measure. I don't know.
Then how do you know it's doing it?
Based upon the previous measurements where you could measure it.
What measurements? When have you
Things
ever
like
measured
we can see that the atmosphere goes slower as we go up.
There's actually a point where I guess they actually say that it's going faster as you go up.
Yeah, I don't know how.
Yeah, I don't know.
Winds,
Do you have that article handy? I'd like to see how you're misinterpreting it.
I mean, just from a very quick Googling, that's a result I got that I posted in chat, where it picks up speed up until about 14 kilometers of height, and then it starts decreasing, and all of this gradually, and then it gets to a new point at about 25,000 kilometers, where something new happens and the wind speed starts picking up again. Now, the exact conditions and why this happens, that's something you'd have to research, but that's what's
wind
given.
speed. That's wind speed. That's thermal. That's weather. That's not
Well,
air
actually,
moving
So
because of the
actually, Rakia, if you your brother's a pilot, ask him, hey, why does the wind actually shift direction slightly when you go up? That doesn't actually have to do with the jet stream, and that's actually part of it. It's actually that it doesn't change speed the way we perceive it in aviation. Is that you get actually a slight deviation in the
Are you
direction
serious?
the wind's going.
Are you wanting me to ask my brother why we have different layers of air
Rakia,
movement?
you heard my question. If you don't want to
I
ask
don't
the
need to
question,
ask
then
my
fine.
brother. I know what causes it. I mean, we
What causes
do
it,
have,
Rakia?
yeah, we have different pressure and different temperatures that's causing convexity, like thermal energy.
That's not convection is up and down, genius.
Right, it does go. That's what creates the layers, though, and
That is
the wind.
not what create convection is
And
not
it
what
does
creates
go
the
up and
layers.
down. You do have thermal.
Convection is not
So
what
are you
creates the layers.
disagreeing with me that thermals don't happen?
I didn't say that thermals don't happen. I'm saying that's not what creates the layers.
Well, that is part of it, right?
No, it isn't, Rakia. That's not
Sure
what
it
creates
is.
the layers. No.
Sure it is. It's part of the system, the atmosphere. How weather is created by what?
Have fun not understanding anything about layers. So
please explain to me. I don't know what your problem is. Tell me how you can differentiate between the air moving because of Earth's rotation and air moving because of the dynamic system that we live in with thermals and different pressures. Yeah, that's what I'm asking. And you're trying to step in here and save these guys when they're talking about heat. Yeah, we know heat causes air movement and water movement. Hello?
That was the first time I ever heard
Maybe
that it
ask your
speeds up.
brother.
That was the first time I ever heard that it speeds up, slows down, speeds up. I thought it just got faster.
No, of course it moves in different at different layers and different speeds. That's what weather does. It's pressure, barometric pressure.
So why does it?
When they
Why
talk
does it
about that,
increase and
when
then
they talk
start
about that, they're
decreasing?
talking about in reference to the ground, not like just regular wind. This is the air movement and reference.
Yeah, but the point is, why is the air movement? If you're saying the air is moving because of the rotation of Earth, then how do you differentiate?
Exactly.
Where do you measure?
That's a good question.
Exactly. Where do you measure that?
That would be averages.
The question is, as a whole, how does the atmos move as a whole? Not what happens inside the atmos. We know there's wind currents in that. Rakia is asking, as a whole, when does the system, at what height does it stop rotating? That is the question.
How do you even know that it is rotating because of that, and it's not just the thermal and the weather?
Shoot a cannon. Apparently, it's supposed to land away from the cannon.
So far, I've
But
got
we'll
Ask
see.
My Brother. I've gotten a Google wiki search and a bunch of silence. Not
You think that
looking
was a
good
Google
for you.
wiki search?
That's what you told me you did. You said I did a quick Google search. Were you lying?
Yeah.
You thought
I did
I
a
was
quick
going to
Google.
forget that you said that?
I did a quick Google search, but not wiki. This was from ResearchGate. This was from a published paper.
Oh,
that I
sorry
found
about
this.
that. Sorry about that one
Yeah.
word I said, wiki. So far I've got Ask Your Brother, a quick Google search, and a bunch of silence. Is that better for you, sweetheart?
Are you saying that you didn't get any other response than that? Because that would be incorrect.
Yeah, silence.
No, you got more answers than that.
Do you have an answer, yes or no, guys? Stop playing games.
We have answers, yeah.
Let's hear it. What
How
height?
did you measure? Differentiate between the Earth rotation
Oh, that's
causing
not
the
one
air
of the
movement?
answers we have.
Oh, boy.
Please give us your answer. I'm dying to hear it. Go ahead. The floor is yours, sir.
Well, answers usually need a question.
At what height does the atmos stop rotating?
You mean
very simple?
in the atmosphere?
Rakia asked it several
Should we
times.
speak one language?
Yeah,
Did you
go
hear
ahead.
me
Which
earlier?
language would you like? I can speak a few of them.
All right, speak Swedish to me, please.
I can't do that.
Can you explain to us why you're using Atmos? I mean, that's not a
Because
word.
air does not make a sphere. So I don't use atmosphere, I use Atmos.
Well, we have an atmosphere in a room. In fact, in caves, they have an atmosphere. So the sphere has nothing to do with its spheroidal nature. It's just the word that we use. So why are you changing that word?
So you're trying to change the subject. We're not going to let you off the hook. Either you know the answer to what Rakia asked you, or just say, I don't know, man. Very simple.
I don't know. I think you have
Now,
to phrase the
I
question
said
in such a
earlier-
way that I can't look it up because I have no idea.
I gave an answer earlier.
No idea. Okay, you're
I
gone.
gave an
How about
answer
you,
earlier.
Gummy?
You didn't
No, you're
really
going.
care about it, though.
What was your answer earlier?
My answer is you'd first have to define what it means for it to stop. Because at no point is air completely stagnant. There's always things like thermal that makes it move. So the actual question should be, at what point is the influence of Earth's rotation no longer affecting its movement? That would
There you
be
go.
the
Answer
better
that.
question.
Awesome
And now the
question.
answer to that is I don't know.
Thank you.
Thank you very much.
So, no shit.
after the obfuscated
teeth.
about
Yeah.
the wiki and a bunch of other stuff. Yeah, we know you don't know. That's why we're asking that very simple question. That's why I've been asking it for 4 years. Shouldn't you know, though? Wouldn't that make
No.
you question? No.
Not really.
It's completely irrelevant.
So it's just theory, right?
It's irrelevant.
Okay, it's irrelevant, but it's just theory. It's not proven.
It's not
something
just
that
theory.
you can measure.
What
Well,
makes it
it's
just
irrelevant?
theory?
Your model, the whole existence of your model rotating, everything depends on your model rotating. And you're telling me that's irrelevant?
The,
I've heard
the
the
speed at
irrelevant.
which the atmosphere moves 10,000 miles away from the surface of the Earth is irrelevant to the question. It
We've
is
shown-
something that probably could be predicted, but I don't have an answer for it. Big deal.
Yeah. Like we've shown that for many kilometers, it moves exactly as expected on a globular. If you want to talk about what happens
No, you
100
stated
kilometers plus, well, okay, then that's on you to do, but that doesn't change anything about what we know so far.
Rocky, I've
You know
heard, and I
nothing
know,
so
and
far.
I know
It's
you've heard,
apparent.
Rocky. That's it.
Say again,
Sorry,
Jeremy.
Jeremy.
No, I was gonna say I know you've heard it too, and I've heard it also that it rotates with Earth forever. Conservation of momentum. It can't end. It doesn't
Yeah, I
end or
always-
run out or get slower.
I'm glad he quantified it. That's pretty cool. I just want to know how he knows that's caused by the air movement, caused by the Earth rotation, and not just normal air movement.
Yeah,
It's
they keep
wind, right?
forgetting conservation of momentum that they throw around left, right, and center. Hey, conservation of momentum, right?
That's what I'm saying.
You like that,
And
Moyak? You like
has
that
to
one?
go- That's ever been on Earth that has this escape velocity thing. Hot from the sun, but somehow the gas underneath it doesn't get hot. Anyways, all that gas has to keep its momentum with the
Don't get me
rotation of
started
Earth.
on that. Don't get me started on
Do
that.
you-
Yeah, that's
Big question. When you say something gets hot, what is temperature?
Temperature?
Yeah, what is temperature? Like if I say that this
Energy.
thing, yeah, but what
I
form
don't
of
know.
energy?
What's energy?
I don't know. What's up? What's the point?
It's okay to say you don't know, but I'm just
No,
trying to see.
it's
Earth heat
energy.
or whatever.
Yeah,
What's
but
the
what
point?
form of energy? Just saying energy is meaningless. What form of energy?
No, it's
What's the
not.
point
Because
with
if there was
the
no
heat thing?
energy, everything would be at 0 degrees Kelvin. So energy is heat, for fuck's sake.
It's thermal
What's the
energy.
point?
What are you asking?
So what is thermal energy then?
It's
What's the point of this?
what
Yeah,
is
I don't
thermal
know.
energy?
If your
What does
en-
that have
if your
to do
answer
with
is
what we're talking
100
about?
definitions.
If
Let's say
your
I
answer is
tell
just
you it's the
it
sun.
is,
Thermal energy comes from the sun. Okay, what next?
no, it's not where it comes from. Talk about what it is.
Who cares? We're talking about the
Of course we
atmos
care.
rotating. That's what we're
What-
talking about.
And if
Yeah,
you
so
like
you
said
have
before,
you have the gas. Hold on, man. You got the gas up. You got the gas up top. Conservation of momentum with Earth. It's rotating with Earth. Then it leaves Earth's atmosphere. supposedly, and then it has to keep continuing that conservation of momentum. It doesn't run out. All the gas that's ever left Earth has to be rotating, with it. It's conservation of momentum.
No, there's other things that are interacting with it. So, I mean,
Very much
there at
true.
some point, something is going to happen. It's going to collide with something.
With what?
So I don't know what
What's
will
it gonna
happen. I don't know the
collide with?
exact what will happen. Like, with as you get like 100 miles up, 200 miles up, 300 miles up. I don't know all the forces that are acting on it to choose to control its direction.
Sure, we know. Sure, we know. We know. Well, you guys know in your model, there's a vacuum up there. It's a little bit of a problem for you.
It's so funny.
Yeah, it's a little bit of a problem for you, don't you think?
I mean, since we don't know what heat is, do we even know what a vacuum
goes
is?
out past the moon now, remember?
Oh, so Gummy,
that's-
do we know
that's
what this is, or do we know
Such
what
a
that
childish
is?
thing. You've had explained to you 1,000 times.
Because knowing what heat even is quite important to what question Jeremy stated, but we couldn't even get anywhere with that other than you saying, but it's just thermal energy. It just is thermal energy, and then nowhere else with that. Do you not see that is a little bit?
Listen up, Gummy Bear. You're not smart enough to do what you think you're trying to do now, right? You're trying to switch things around to ask us questions. What the original question was, what altitude does the Atmos stop spinning? And you're bringing water from 100 different wells. And this is
part
great.
of the answer was talking about temperature, and then on top of that, Jeremy came in and asked a question about why things like why the top layer is escaping and not the bottom layer when the bottom layer is getting thermal energy as well, and all of this blah 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 blah, which again is talking about temperature and thermal energy and all of these things. And so I asked the simple question, what even is temperature? Now you guys couldn't answer that, and that's fine. It just shows that you have no idea what you're talking about, and you didn't want to continue
You
that
haven't
line.
told us yet. Do you know?
Yes, I am aware.
Okay, go ahead. In your answer, tell us what temperature is in thermal energy. Go ahead.
Temperature is the average kinetic energy of the system.
Yeah, that's what they said. Energy
But
release.
none of them said that.
Yes, he
So-
did. The one guy said energy.
Okay, now it's just, again, like I said before, just saying energy is meaningless. I
You gotta say
quantified
kinetic energy.
that it's kinetic energy, which means things are moving.
Okay, you quantified it. Okay, so what? What happens now? Now we quantified energy. How does that relate to the Atmos? Please go ahead.
Okay. Now let's say the
Things
heat.
move
Remember
at
the
0
question,
degrees Kelvin.
the height.
No, they don't.
Go on.
Well, I'm being interrupted every time I speak. So you can
I
say
just
go
want
on
you
as
to
much
make
as you
sure
want.
that you relate it to the height of the Atmos and when it stops spinning, sir. Please go ahead.
So do you want me to ignore the thing that Jeremy brought up? Just ignore him as if he's not part of the conversation and just go back to the one
Dude, would
question?
you carry on? This is getting weird that you're
No, I'm
obfuscating
asking
so
a
much.
question.
Just do whatever you want to do. If you want to answer Jeremy as you answer SC, go for it. Can you do it? Or can you just stop obfuscating? It's so stupid. It makes you look terrible, man.
Are you sure I'm the one obfuscating and he's not being
Yes, you.
Okay, answers Jeremy's question and then get back to mine. I want to see what else you're going to ask. Maybe we can define the term it or of after. Go ahead. Answer Jeremy.
Okay. Now, Jeremy, even if, let's say you heat stuff at the bottom, like right close to the ground, you heat the air really high. All that means is that the air down here has really high average kinetic velocity. But the thing is, we have a bunch of air around that air, and so it's not just going to fly out into nowhere, it's going to bump into the air next to it.
Bro, I didn't say anything
Yeah.
like what you're saying. This is some kind
No,
of weird
hold on.
straw man. I
No.
was referring to the
to
the sunlight. So far I didn't say anything about the shit you're saying.
Okay. Now if you don't see the connection, that's fine, but I'm getting there.
Connection to what? Oh, the shit I didn't say?
So, okay. Do you know what you said earlier?
My God, dude. Go on, dude. You're the obfuscating king.
Just because he doesn't understand that he asked a
Explain
question.
it to him. Explain it to him.
me what I said first. Get back to the conversation that was happening.
Okay, I'm gonna ignore you, Jeremy, and the question you stated because you don't seem to remember it yourself. Let's just pretend that didn't happen.
Maybe kicked.
You're lucky I'm not a mod now, dude. You're very lucky.
This is
Hey,
ridiculous.
Gummy Bear, why is it that you're able to admit that you don't know what they were asking for? But when I asked you about the planes that can fly at 1,200 miles per hour and hover and 40,000 pounds of thrust, and they can go wherever they want and fly in a straight line, they could never see the west to east rotation. You're so sure they could never see west to east rotation. Why can't you just say you don't know for that one too? I'm not trying to bring that conversation up again, but I just reposted the gifts. And
well, because that
when I brought it up, Moyak did the same kind of obfuscation technique that he's doing right now. Neither of you guys can admit that you don't know if the plane could ever capture with a camera underneath the plane, show that west to east rotation, and it can do whatever it wants. It flies wherever it wants.
Obfuscation? The fact that I bring it down to reality and I say that it's not a practical test, and you say that's obfuscation? No, if you could get an airplane to fly like a bullet, you'd see it. You can't get an airplane to fly like a bullet,
perfect.
so let's go on to the next possible test. Instead of following through with
this thing can fly like a bullet.
It doesn't function.
So the answer perspective is because
it can fly like a bullet. It can go dead reckoning. It has 1,200 miles per hour speed. It can hover in midair with 40,000 pounds of thrust. You're saying
Can it hover at 1,000 miles an hour?
Can it separate from the atmosphere?
Excuse me. Did SC's question get the answer, or are we moving on?
Yeah, I don't mean to do that. I'm not trying to move it on, but I think that I was trying to stop Gummy Bear from just keep drilling Jeremy over stuff that makes no sense to even ask.
The whole argument makes no sense. It's totally irrelevant.
I agree, because the Earth doesn't spin and the atmosphere isn't being pulled around by the Earth. The Earth is stationary, and the air above us is moved by all the things we know makes air move, which you are stating. Kinetic energy is created by thermals. I mean, the release of, so it would happen over a flat plane then, right? A non-moving Earth?
You would still have movement of the atmos, if you want to use that word, on a flat plane, correct? Yeah, we're not denying that.
I agree with you, and if you can't differentiate between the Earth causing it to move or the things we know that causes it to move, then why would you assume that the Earth is causing it to move at all?
So we can differentiate, and the way we differentiate is because we have effects on the air that wouldn't happen on a flat Earth. For example, Coriolis.
Oh my god!
Oh, that's why I'm bringing up the whole jet thing.
Oh my
god! Which happens with a bullet projectile, but no other projectile that actually can capture that movement.
What do you mean, no other projectile?
Like the plane that can fly 1,200 miles per hour.
A plane is not a projectile by definition.
It can mimic a projectile.
No, it cannot, because it cannot separate from the atmosphere.
Oh, you mean the bullet's separated from the atmosphere?
The bullet is shaped in a way.
Delusional, bro.
The bullet is shaped in a way which has minimal interaction with the atmosphere. Correct.
You said it separates with the atmosphere. You said the bullet somehow separates from the atmosphere.
Now, I just said the bullet is shaped in a way where it has minimal interaction with the atmosphere. Now, that's not necessarily separation. That is minimal interaction. That is kind of what we talk about when we talk about separation. But okay, I've clarified.
So you're saying the bullet, Earth rotates underneath
You got
the
excited.
bullet?
You got excited.
Sorry, Jeremy, I didn't hear what you said.
Earth rotates underneath the bullet.
Well, that's a very simplified way of saying it, sure.
What do you mean? What do you mean?
That's the literal way of saying it.
What do you mean?
Is the Earth not rotating under the bullet, or?
So the relative rotation of the Earth bullets are in a slight mismatch due to the bullet transfer or traveling into a region of changed rotation.
You can't answer a simple question, Jeremy. Is the Earth rotating under the bullet?
Just answered
yes or no? Rotation or no rotation? Yes or no?
It's not a yes or no question. Or like, that's not how you answer every question.
Unbelievable, man.
But you're saying that if this jet plane was to go over the Earth and fly around the world north to south, 300 or 400 times or however many times, you're saying that during that time, it would always, the winds or the atmosphere would always cause this powerful jet to somehow keep in the illusion that the Earth is stationary below it, no matter what it did.
Essentially, yeah.
Wow. Nicely done, bro. Nicely done. Delusion.
wouldn't
You
this
guys
take
are living
north-south?
in fantasy.
Take north-south flights longer, depending on if you were going north or going south? Going north. If I'm going north, I have to keep up with I'd be chasing the rotation, whereas if I'm going south, I'd be, stepping into it essentially.
Wait,
No?
Yeah, it would have
you're
to
talking
speed up and
west to
slow down to
east,
every
not north to
tangential
south.
speed. It would be going every tangential speed exactly perfectly so that it would always maintain the illusion of a stationary Earth, because the winds would force this powerful jet to always maintain that illusion no matter what.
Not no matter what, but in
Yeah, it would
every
be sideways. It would go sideways, linear acceleration, by the way, sideways acceleration, so that it matches the 1,000 miles per hour at the equator, and then it would match the 750-mile latitude. Then it would match the 500. No matter where it goes and no matter how fast it flies, it's always going to maintain that illusion of a completely stationary Earth.
now.
But a bullet
Yeah,
would be able to see it.
what I just said is no always, but at the speeds of which our current aircraft are capable of, yeah.
Well, the one I put in there, the 1,200 mile per hour jet that has 40,000 pounds of thrust. Just put cameras on the bottom of that. We can see the Earth rotate. Have this over tomorrow.
Very simple.
Sure. Very simple.
Okay, so you agree, because
realize-
most ballers, in fact, you were last time I asked
No,
you this,
I'm not
you kept
saying.
saying, and you, in fact, you just said that no matter what it did, it would always maintain that illusion. But now you're going back on that and saying, oh, you would be able to see the rotation.
So the thing I said yes to is whoever went in and said very simple. I said yes, very simple. But your thing.
What? Yes to what? What were you saying yes to?
To the cameras on the bottom.
No, someone came in and said very simple, and I said
That was
yes,
me.
very simple.
That was me.
Yeah.
That was me.
Okay, so what did he mean by very simple when you said yes?
It was more of a
doesn't matter, dude.
sarcastic yes to his yes, very simple.
Oh no, you said I said if everyone was here. It doesn't matter. It doesn't. Now you're agreeing that you can see the Earth rotate with camera.
No, I did. That's not what I said yes to.
Okay, so what are you saying? Are you saying that this plane could fly around the world north to south as many times as possible, and it would always speed up to the tangential speed sideways, and would always maintain the illusion of a stationary Earth in respect to its own motion? Is that what you're saying?
Completely in respect to its own motion?
Yeah, it would be completely
exclusively
stationary. Just like anytime we're in a plane, the Earth is completely stationary in respect to our north to south movement.
So doing that alone, no. You'd have to take the wind direction into account as well.
Well, yeah, but I'm saying, so you're saying the winds would cause this jet to always be either slowed down or sped up, no matter which tangential speed it goes to. And it would perfectly always see a stationary Earth relative to its own motion. You're saying that the winds make it do that.
Kind of. I wouldn't say that encapsulates the entire picture.
Okay, what else besides winds?
I think one of the things, the difference between the Coriolis effect in that situation, where the airplane will sense a crosswind as your tangential speed decreases. There's a crosswind that also assists you in decreasing your tangential speed. So essentially, what you would see is a 2 mile an hour wind crosswind on average as you were flying across the Earth, and as
are you sure only 2 miles an hour?
Sense that if you were able to measure it from the ground, you would not see that same 2 mile an hour wind from any point on the ground.
Yep.
So the plane will
let me
sense
give you a
the 2 mile an hour
scenario.
wind, but it won't be on the ground.
Let me give
So
you
you're
a
saying
scenario.
the winds would always make the jet forced to be within the illusion of a completely stationary Earth when it goes north to south. And it would constantly be speeding up sideways to match the tangential speed, no matter where it went.
I'm showing you that it's an illusionary wind. That that the wind would not be measured from the ground. No,
The
no.
illusionary
If you actually listen to the words I said instead of cackling like a child, you'd actually understand what I was saying. But
You're talking
want to
nonsense.
cackle like a child.
Okay, let me
please explain
simplify.
illusionary
Let me
wind. Oh, I want to
simplify
hear
what
this.
he's
Please
saying.
explain.
Let
Please
me
explain
try and
illusionary wind.
let me try
It
and
does sound funny at
simplify.
first. I have to admit.
Let me try and simplify. You have an aircraft that's flying, let's just say, perfectly north. Now you see a little bit of a deviation sideways. You look at the wind speed. You see, oh, okay, I have a wind that's going to the east at 2 miles per hour, and that's why I'm being pushed to the side. All good so far. But let's say someone's right below that plane on the ground measuring the airspeed. They might be having 0 miles per hour wind, even though that airplane was measuring 2 miles per hour side wind.
So because it's higher up, it's illusionary?
No, I'm not saying it's because it's higher up. We're talking about the... Sorry.
Like if he had a balloon floating over his head, the balloon would be stationary, just floating in a column of air. So we know there's no wind reference to the ground. Yet the airplane is sensing a wind. Because it's an illusionary force. It's an illusionary wind.
Oh, you mean the wind that
caused
has
by
to do
the
with
Coriolis
effect?
It's caused by the fact
Oh,
that
the illusionary wind is the Coriolis wind. Is that what you're saying?
This is unbelievable. Illusionary wind. Wow, guys. Wow.
And fictional force of the illusionary wind. I like that.
Well, instead of laughing, address the point. Now, I don't know how you test this, but I'm just saying, if I'm correct, that if I put up a balloon and it was stationary, we could, at the height of that airplane, we know that that airplane is then, therefore, and that airplane, as it crosses that balloon, says, no, there's a 2 mile an hour wind, crosswind. Now, what are you going to do?
What is that caused by?
This
What's that
illusionary
wind
wind
caused by? What's the reason for that wind?
This is
And
how
why
you
is the
would
balloon
define it, you
feeling
moron.
not feeling it?
That's not this. I'm not even staying here. It's not
The
worth it.
cause...
What? Depends on how you define it. I'm a moron because I don't know how to define illusionary wind.
This is too good.
No, I'm talking to
pseudo
Nancy
force.
Montreal and his fucking stupidity.
Hold on, Moyak. But I just want to make sure you're saying that you think that the winds, this illusionary wind at 2 miles per hour, or whatever it is going to cause a jet that has this kind of power to always, even if the pilot is trying to resist those winds and trying to go in a straight line, dead reckoning, and it has that powerful jet and it wants to go wherever it goes into the jet stream, out of the jet stream, goes into any speed, and it can never see a rotation below it.
An airplane in a 2 mile an hour crosswind, if it doesn't adjust for it, will eventually start moving 2 miles an hour to the side.
So it's forced to, is what you're saying.
No, we adjust for it. That's why you can't.
No, what if he decides not to adjust for it?
Never adjust your controls again. But there's this 2 mile an hour illusionary wind that is greater than you would see with the balloons on the ground. Like I measure the speed of my balloon on the ground, and I say, okay, that balloon is moving 22 miles an hour west. And I see that airplane going, and it says, no, I see a crosswind of only 20 miles an hour, because so now you measure the difference, you can see that there's 2 miles an hour that's not accounted for on average. So you can
what
do this
instrument
in actuality.
What instrument would you use to what instrument will you use to detect this illusionary wind?
You would have to do the cross comparison between the airplane and probably a series of balloons where you actually monitor the speed and then compare what the airplane says it has to do in order to follow a straight line. So you take
regardless of all that,
regardless GPS is accurate.
Okay, but regardless of that, you're saying these illusionary winds is the reason that this jet would always be forced to speed up sideways or slow down sideways to match the tangential speed of wherever it goes, so that it would always have the illusion of a stationary Earth. It could never see any rotation, no matter what it did.
If we determine that, well, it doesn't show a stationary Earth. It shows that it will.
In respect to its own motion. Stationary in respect to its own direction, north to south. Yeah, it would never go sideways underneath it, west to east. You would never see that. It would always have the illusion of a stationary Earth in respect to its own north to south travel. No matter how far it flew, no matter how many tangential speeds it flies over, no matter how fast it goes, the winds are always going to make it completely match that tangential speed. So it seems like the Earth is not rotating. Is that what you're saying? I don't know. I feel like this would be noticeable, and like flights would take longer if you're going like from the equator.
Yeah.
Like say you were going from the equator to, I don't know, Alaska or Sweden, somewhere way up high. In one instance, you're going to be trying to catch up. You know, you're going to be trying to you'd be chasing your target essentially in the plane. And on another instance, it would shoot right into you, and you could just like go straight down and lead it, and it would spin right into you essentially.
Anyway, I just jumped back in. I don't need to bring it back to the airplane thing, but Moyak's deafened himself now, so that says all I need to hear.
Ah, guys, Moyak has this good triangle thing.
Well, he ran away like a little girl because of, there's no answer to this. He knows he has to make up stuff. He knows it. And so does Gummy Bear. That's why he's silent now.
Yo, you guys got to get your audio straight over there, SE. You come in mad loud, like Bev will be like low, his mic will be like low, and then you come in mad loud. Like I can't even find a middle ground when I'm watching the videos.
Yeah, I
Do
hear
you
it. A
guys
lot of
really
people say that. Yeah, Bev comes in really low. I know, man.
And you come in dumb loud, like
Yeah.
like happy medium. Yeah.
Am I very
just
loud
wanted to
now?
let you know.
Am I very
No, you
loud
sound
now?
fine now. It's just in the YouTube videos.
Yeah, thanks. You're not the only one. Thanks, bro.
Yeah, no problem. I was just letting you know.
Do you guys really think that the only reason someone would become quiet is because they've been stumped by your question?
So what's the answer, Gummy Bear? At what height does the Atmos stop
Are
spinning?
you just going to
Very
ignore
simple.
that question?
Well, maybe I was wrong. My sincere apologies. Maybe you had another reason to be quiet. Now that we have established that, would you care to answer the question?
It has already been answered.
No, it hasn't.
Maybe not to your satisfaction, but it was answered.
Imaginary air?
That wasn't my answer. That was something Moyak brought up.
I think it was Illusionary. Illusionary
air, yeah. So come on, Gummy. Let's have it.
I've already given you my answer. I don't why should I have to repeat myself?
I don't believe you gave a satisfactory answer.
Okay.
You said I don't know.
That's
maybe
on you. That's on
Did you
you
say I don't know?
You don't care about my answer.
Did you say that you don't know?
I said that part of it I don't know. I clarified which part I was unaware of. Yeah.
Okay, so you don't know. Fine, I'll accept that answer.
If that's how you want to just summarize my position, then that's fine.
Well, correct me if I'm wrong, sir. You have a chance now.
I told you that I gave a clarification on which parts I don't know. There are some parts that I do know, and I clarified those, but some parts I don't know. You know how you can have incomplete amounts of information? That doesn't mean that you don't know anything. It just means you know some parts and not others.
Yeah, but this
Enough
isn't
to be
difficult.
dangerous.
You have a globe, it's spinning. There's an atmo around it in the shape of a sphere. It spins, and it also in your model, you have a delineation point, which you call space, which you call the vacuum of space. Now, why is it so hard for you to say when this stops spinning, or if it does? You should know this stuff. This is elementary to your model.
I told you.
Sure.
I've told you. Just because you don't remember my answer doesn't mean I didn't tell you.
So it would really be hard for you to repeat it. It would cause so much pain for you.
English.
I've already repeated it twice. What is repeating it a third time gonna do?
I don't even really remember. There was so much stuff going on.
Yeah, there was so much stuff we don't remember. What's so hard of you repeating it?
Because I'm just gonna end up repeating it over and over and over, and we're getting nowhere.
So the air is going up, it's all rotating with the Earth, and then at some point, or does it keep going forever? I forgot which one you said.
Yeah, I said at some point you reach a level where there's just not a lot of air to keep up that rotation, and stuff like thermal energy, which is the average kinetic energy, is gonna take over as the major contributor to the movement of the air.
So the air that was there, that's the other air has been, so conservation of momentum, like it runs out. You're saying?
No, what I'm saying is all air everywhere is moving to some extent because it's not a 0 Kelvin. The actual question we should be answering is, where does movement due to the rotation of Earth stop? Because there's always movement. I hope we both agree on
He's
that. As long
asking.
as there's
That's what
we're
That's what we've
asking
been
you, bro.
asking.
That's the whole thing we're asking you.
The question you said we should be asking is the one we've been asking.
Yeah. And the answer to that one is, how would you ever know?
That's your model. You should know. Of course, we don't know. We laugh at this, bro. Listen to
How
Rakia.
would you ever know? Yeah, exactly, buddy. You don't know. You just believe. Theory, faith, religion. Pretty much the same thing. You don't know.
It's a
Again,
model affliction.
you're applying the I don't know to a bigger picture than the part that I said I don't know to. But that's
If you
fine if you want to
don't
keep it that way.
know, you have to take it on faith, brother.
So we know the concept, but we
Yeah,
don't know
theory.
the exact point of which this happened, because that is irrelevant.
If it
No,
happens.
you only know it if the Earth is rotating.
Let me ask you this, Gummy. Where the ISS is, or the fantasy ISS, shall I say, is the atmosphere rotating there?
Is the atmosphere rotating where the ISS is?
Yes.
Mm,
Google it.
I'm actually
Google
not
it.
sure. Yeah,
Well, there's air there, right?
a very small amount.
Yeah, but there's atmosphere there, so you must have. Is that the atmosphere that's rotating with the Earth still at that point, or? Yo, you know what's fucked up is Earth gets hit with 25 million meteoroids, and micrometeoroids every day. 25 million, which isn't a problem for us because they burn up in the atmosphere, which the Globers will be quick to tell you. However, what's not okay is for the stuff that's above that, like the ISS, the thousands and thousands of satellites that are going through a shooting gallery every day that somehow manages to be fine at the end of every day.
That's another good point.
25 million a day, moving at absurd speeds, crazy speeds, space speeds.
Yeah, all a fantasy, all in their minds. As you can tell, you ask them a few simple questions, they buckle and they mute and they go crazy. Yeah.
I wanted Moyak to show you guys these triangles he's got on his globe.
I'd like to see that as well. Yeah.
Yeah, he's got
More
a
than
little globe
180, I
thing.
imagine. More than 180,
Yeah,
Jeremy.
yeah.
Yeah.
Of course it is.
Well, it's three different triangles, but
Did he tell you with what he measured the angles with? Did you ask him that?
yeah, he did. He used a protractor. He's using straight lines.
He used a protractor. Nice.
Yeah. It's straight lines. He had a little globe. I think it was like his wife's globe or something. Stuck little toothpicks to it, coming straight up out of it.
Yeah, we got these guys dancing, man. They're it's
Yeah,
become a
that
comedy
is
now.
true. That's true. Yeah. But Moyak enjoys it. Enjoys drawing triangles on a probe on his desk, doing little things like that.
I mean, I
Maybe.
heard before that the atmosphere speeds up as you get higher. You'd expect to see drag and have it slow down, but somehow it speeds up.
Well, what would it be dragging? Hold on, what would it be dragging on?
Well, I don't know. These other particles that the air is bouncing off of that's stopping it from rotating with the Earth forever.
Well, if the air is bouncing
Maybe
off
the
other
moon,
air,
the sun. I don't know.
if the air is bouncing off other air, then that energy is retained within the air. So there's no drag on air by air.
So the atmosphere
Do
is
you not
rotating.
realize
So
that's
that
a bit of a nonsense?
excuse you used earlier about the air is bumping in other air, so it wouldn't be rotating forever is nonsense now because of what you just said just now, right?
No, that's a different
Earlier,
scenario.
the air. You told me earlier the air would be stopping because it wouldn't be rotating with Earth forever because it's interacting with other air molecules and bouncing off them.
Correct.
Rotating forever.
But you're saying, wouldn't there
And
be
now
drag?
you're saying,
hold on. But you said, wouldn't there be drag to the air moving around up there? And I asked, drag on what? And you're essentially
drag
saying
from
other
all
air.
the air that's interacting with the other air that's causing the air not to rotate indefinitely for all of infinity with Earth, like you proclaimed earlier.
When all of the air is moving together, what is there to drag on?
So all the air is moving with Earth for all of infinity. Earlier you said it wouldn't be because it would be interacting with these other molecules that would be giving us drag.
How is this
You
my
can't have
fault
it
for
both
you
ways,
not
bud.
understanding the difference in the two scenarios?
Tell me I don't understand. You're trying to have it both ways. You can't.
So it is not both ways. It is two different scenarios in which
it can't be both ways.
they're not the identical scenarios, so it can be.
One scenario, you have gas molecules interacting with other gas molecules, causing the air not to drag, air not to rotate with Earth indefinitely.
When
now in this scenario, I have the air molecules that Earth's spinning with, interacting with other air molecules, which would cause drag because it's not all spinning together. Have it both ways, you can't. Sorry.
Isn't flat Earth with its own rotating atmosphere above a stationary Earth even weirder than an atmosphere moving around with a planet?
Gummy, what I was going to say earlier was you have the sun heating up the... Go ahead, Don.
Yeah, the flat Earth rotating atmosphere. Totally absurd and unprovable.
Anyways, what I was going to say earlier, Gummy, was you guys in your model, you got you've got the sun heating up the top layer of atmosphere so much that it causes those particles up top to get so hot they reach orbital they reach
escape velocity. Yeah.
Escape velocity, yeah. But if the sun was interacting with gas molecules like that, or as the sun passes through them, or as the sun interacts with them, our atmosphere would be very hot up top, and then it would get colder as you went down. Full story I don't buy either about the escape velocity of gas molecules and shit.
Have you ever heard of the thermosphere?
Yeah, I heard of the thermosphere, yeah.
Yeah. So that's the part that gets very hot, the sun.
Okay, I know. Yeah, the sun heats up the gas. The sun heats up the gas up top. Yes, I just explained that. And then you get lower, the sun stops interacting with the gas and passes right through it to the ground and radiates the heat there.
When you get lower, you have more air in less space, which means there are more things to heat up. And so the same amount of energy won't do as much in heating it up. If you heat up a pebble with 100 joules of energy, it'll have a high temperature. If you heat up a bowling ball with the same 100 joules of energy, it'll barely change. And so in the thermosphere, where there's a very small amount of stuff, they will get very warm from the same amount of energy. But when there's get more stuff, they don't get as hot from the same amount of energy. It's not that difficult.
So you're saying the things in the thermosphere get hotter easier?
Because on one hand, they are smaller.
I'm sorry, that was a clarification question.
Yeah, essentially, yeah.
So what kind of stuff is in the thermosphere? Do we have anything there? Did we put any man-made stuff there?
Any man-made stuff? I'm pretty sure ISS is considered to be in the thermosphere.
Yeah, so it's getting hotter easier.
No, because the
right?
ISS is
no, not.
because the ISS is a very big thing. So that heat is being spread over a lot of things again, which was the problem further down. So it doesn't have that same problem.
Things is the ISS one thing, or is it like a million things?
I mean, it's compromised of a bunch of things. You can consider it one thing or compromised of a bunch of things. That's
How
more
many
of
things?
a definition problem. Well, that depends on how far down we want to go in category. We want to talk about how many modules, how many atoms, what is talk about.
I don't know. You're telling me stuff gets hotter easily in the thermosphere, and then we got stuff in the thermosphere that manages to not get hot. So it's size dependent. You're telling me if we put something really small up there, it'll get really hot, but if we put something really big up there, it won't.
Exactly. The same way that if you put a little bit of energy in a pebble, it'll get hot, but same amount of energy in a bowling ball barely changes it.
So how small does the object? Where's the cutoff line between it getting hot or not?
It's a gradient. If it's very small, it gets very hot. If it's a little bit bigger, it doesn't get quite as hot. If it's a bit bigger, it doesn't get very hot. It's a gradient. I don't know how else you want me to answer it.
How big and how something the size of a screwdriver or wrench? Is that big or is that small?
That's very big.
Very big screwdriver, very big. Yeah, even one of those little tiny screwdrivers.
Yeah,
very big.
Because it has a lot of molecules in a compact place. It has the density of whatever it's made of, which probably is some sort of metal.
What about a little tiny wire? How about a little wire? Is that big or small?
It would. I mean, it's if the main thing you would think about is the density. Is it a lot of things in a small space, or is it very few things in a lot of space?
So if something's not dense, if something's so it can be big and not dense.
Yeah. If you say you get a really big but thin sheet and you put it up there, that'll get really hot. Yeah.
A thin sheet would get really hot.
Jeremy, did you go to school?
Hold on. So a thin sheet would get hot, like what? A thin sheet, like the stuff the ISS is made out of, is covered in that
If
thin
you
of a
did,
sheet.
why can't you remember?
Is that thin of a sheet? That would get hot real quick? The ISS
Why do you
covering.
pretend not to?
So such a thing, yes, that would get hot very quickly.
Oh,
But
okay.
do you know what the ISS does? Is it connects that sheet to a coolant system, which has liquid ammonia that takes up and soaks up that heat. It's almost like they've thought about this and they've designed it to use it.
So the ISS is getting crazy hot, but they have a cooling system.
No. A part of the ISS, the sheets that are very big, are getting a lot of energy in them.
ISS, yep.
Is not the entire ISS isn't covered in a thin sheet.
Thick part.
I've never heard of the ISS being covered in a thin sheet. I know that they have solar arrays, which are essentially thin sheets.
Well, that's a whole nother problem for you, is the solar panels, but sure, the ISS covered a little thin sheet. Didn't you ever see the covering where the guy had the little meteorite hit it, he claimed? Or something broke through the little sheet? Little thin sheet?
If it's up there, they will have worked out how to make it survive up there, right?
Yeah.
So what are the questions
I don't know.
for?
I don't know what you're talking about, Jeremy. I'm sorry.
Okay, you claim you got this thing inside this place that's gets objects hot easy, but the object doesn't appear to be getting hot easy. I mean, we have solar panels up there that are black and cased in glass. Do you know what happens if you put something in direct sunlight? Have it be a glass box with black underneath. It gets crazy hot, like super hot, hotter than everything else around it.
And do you know what a solar array does? Instead of absorbing that energy,
a solar array creates electricity for the
yeah.
ISS. Yes, I know what it does. Do you know what the box does?
No, let me
black
finish.
box does? I asked you a question. You're going to ask me another question.
Because you didn't let me finish.
Why don't you answer mine and then ask yours?
Because you didn't let me finish.
Why don't you answer mine and then ask yours, and not ask me a question and we'll never answer each other's questions?
Because I asked you a question, and then the answer you gave, I wasn't allowed to elaborate on before you move on to a different question.
Dude, you don't ask me a question. I asked you a question. Why don't you answer mine and then ask me yours? Or we're just going to ask each other questions that we never answer.
Okay,
all day.
what's your
what you want to do?
question? What's your question?
Circle.
We should just ask each other questions all
No,
day.
I'm asking
that no
you
one
what's
answers.
your question so I can answer it.
Do you know what happens when you have a covered in glass on the bottom of it in direct sunlight?
Yeah, it gets a lot of heat.
Hotter than everywhere else, right? That's what you have going on with the solar panels. Yet the solar panels don't already in this environment. They're getting even hotter than the environment because now it's getting even hotter. So how are the solar panels okay?
Okay, my answer to that is because what solar arrays do is that instead of absorbing that energy as heat, they convert it to electricity. So the energy coming in isn't all.
Heat? You think a solar panel takes heat and turns it into electricity?
No. What I'm saying is, instead of that heat, that light being absorbed and becoming heat energy, it is used to create electricity through chemical interactions.
Box doesn't get hot. Then you can have a black encased box and it doesn't get hot somehow. You're saying
if that box is constantly pumping out energy through some means, then yes, true. Heat is just a form of energy, so if it's losing more energy than it's putting in, then that box could be incredibly cold.
So solar panel boxes on Earth don't get hot because it's using all that electricity, all the sunlight for electricity. That's what you think?
No, I'm not saying they don't get hot, but that's the reason why they don't get scorching hot to the point where they melt themselves.
Great.
Just gonna have to trust you.
Well, you don't have to trust me on that. You can go and talk to any person ever who's designed a solar panel and ask them.
No, you don't have to trust nothing. You already don't believe in the ISS for other reasons. I don't know why you're asking about it.
I can give you the mainstream answer, which I feel like I have a proper understanding of. But no matter how much I feel like I have an understanding of it, you never have to accept my answer for it.
Just because you have an understanding of the story doesn't prove.
Exactly. You don't have to believe me. I can say that I personally believe I have a good understanding. Like that's as far as anyone can ever go, is to say that they themselves have a good understanding of it. I can make up my own system of math and numbers, say that I'm the only one with a good grasp of it. Doesn't make me like best at math just because I know some math that no one else knows.
I'll tell you what. You think to yourself about how an ISS would work on a flat Earth, and just use that explanation for the globe.
Or if you want to, you can go the route of denying it even exists, even though we can see it with telescopes by independent people, but that's fine as well. It's all your own prerogative. You do whatever you decide to.
So is the ISS experiencing Coriolis?
Whatever
No.
consensus says, I guess.
It would not be experiencing Coriolis.
No, you said?
No, because it's in orbit. Why would it be experiencing Coriolis?
So how high up do you got to get to not experience Coriolis?
It's not
So you
that
do
it's
know when
high
the Earth,
enough. It's not that it's high enough. It's that it's in orbit.
when the air stops rotating with the Earth. If the
Is
ISS doesn't have any Coriolis effect out of Earth's atmosphere, not side of the air that's rotating with the Earth.
the air outside the ISS also in an orbit? No, and therefore no. The ISS is in orbit. It's not experiencing Coriolis. That's my answer.
Because if something moves fast enough, no Coriolis, you're saying.
Not just fast enough in an orbit, which is a ratio between its distance and its speed.
Okay, so if I was 3 inches above the ground, how fast would I have to be going for no Coriolis?
Well, that would
Let's
be
hear the
some
ratio.
sort of.
What's the ratio? Or did you just make that shit up? I feel like you just made it up.
I would say.
What's the
ISS
ratio?
correct.
Not you,
The
Don.
ISS
Gummy
correct.
Bear, what's the
Jeremy.
ratio?
And that's how it stays in
All
orbit.
this shit is made
What
up.
an orbit is.
What's the ratio, Gummy Bear? Do you know the ratio, Gummy Bear? I don't know.
I do.
Yeah, what is it?
The ratio is that the acceleration needs to be equal to the velocity square over the radius. That is the ratio.
The acceleration?
Yes. The acceleration.
How much is the ISS accelerating?
Like 8.9 meters per second.
So it's not moving at a constant rate of
second squared, sorry.
17,000. So it's not moving at a constant rate of 17,500 miles an hour.
No, it is. The acceleration is.
So it's moving at a constant speed and it's accelerating.
Correct.
That's weird.
Because it's changing direction.
Were you correct? You said correct to
Correct.
that?
Correct. Do you know that something can
It's
be
moving
at
at a constant speed and accelerating? And you said
yes.
correct.
Because if you change direction, even if you're at the same speed, you have now accelerated.
I'd like to change my answer. I agree with Gummy Bear. It's in its own orbit, independent of the axis rotation of Earth. So
this is a bad time to agree
it only
with
has
Gummy
its
Bear.
own Coriolis from the rotation of itself. Nothing to do with Earth.
Bad time to agree with Gummy Bear. He just told me that something's moving at a constant speed and it's accelerating. I wouldn't agree with him right at this moment. Stop saying correct to goofy stuff. That is not. That is.
You can call it goofy if you want, but it's every Glober should agree with this.
What do you mean by that, Gummy Bear? Is it constantly accelerating forever?
So it is constantly accelerating towards the center of its orbit, but because the direction of acceleration is always away from the direction of movement, it's not increasing in speed. It's just changing the direction, which is acceleration.
Okay, so why don't you run your math? Run your math. Tell me if I'm 3 feet off the ground. Stay 3 feet off the ground. How fast do I have to go for there to be no Coriolis?
They need to develop their.
If it's a simple formula and ratio,
speed.
Simple formula and ratio. Doesn't matter where you are. It's all about how fast you're going according to Earth's rotation or whatever your formula was. Let's hear how fast do I got to go if I'm, say, 30 feet above the ground to not have Coriolis effect. This is going to be funny.
Okay. So would you like it in meters per second?
Yeah, that's good. That's good. Meters per second. This is going to be weird because the other day,
8,000.
Kosha was telling us, did the math for how much Coriolis light had on Earth.
So 7,900 meters per second.
So how do you figure out the Coriolis for light? If you're going that fast, there's no Coriolis.
The Coriolis for light. I actually don't quite know what you mean by that. You mean as if
light's
something
traveling,
was moving? Yeah.
And something's rotating under it. There's Coriolis. Kosho did the math on it to figure out what the Coriolis of light was. But you're telling me if you're going at 7,500 meters a second, slower than light, there's no Coriolis. You guys gotta get your shit straight, man. Why would there be no Coriolis? Moving and in the inertial frame with the ground spinning on. Did the ground stop spinning underneath you when you go that fast?
No.
Still spinning under you. I'd still be deviating from the ground. Straight line path, but no Coriolis. It doesn't even make sense, dude. Come on, man.
Because it would be in an orbit. His motion would be dictated by the orbit.
You shit. This don't even make sense, Gummy. I'm sorry.
That's fair.
Not like it doesn't make sense to me because I don't understand. I do understand Coriolis very well, and what you're saying is just doesn't make sense.
So would you feel better if I said
Hang
that that's what maximizes Coriolis?
Hang on. Does it make sense or doesn't it? Does it not make sense to you?
It doesn't make sense to me. It wouldn't make sense to anyone that understands Coriolis.
That's understandable. If it doesn't make sense to you, I totally understand that.
So let me say this instead then, Jeremy. We can also say that when it's in an orbit, it has maximized its Coriolis. That is
So now
also a
there's
true statement.
now there's the most Coriolis. You've maximized Coriolis when
That's
you're
weird,
orbiting.
man.
Before you told me there was none. Now you're telling me it's maxed out.
It's
Two opposite ends
almost
of the
like,
spectrum.
depending on which reference frame you choose, you either get 0 or all the maximum you could get.
Two opposite ends of the spectrum, right? One, if something has no Coriolis effect, maxed out on Coriolis
That's
effect.
a weird way of saying it, going by. You're going to
Yeah,
break
it's
me
almost
brain.
like
You're gonna break
depending
me.
on the reference frame you choose.
Now the ISS does have Coriolis effect. What do you mean reference frame you choose? There's two reference frames.
Yeah. Which one are you looking at it
You
from?
don't get to choose one.
Well, you need to choose which one you're representing everything from.
Coriolis is in relation to them both. The deviation from the non-inertial to the inertial with something traveling over it. You may be making shit up. Like you get stuck and you start making shit up or
Jeremy,
what?
let me try and explain it in my weird layman dawn terms. Doing an orbit is almost the same as what Gummy said, maximizing your Coriolis. So you put as much effort you can into
maximizing Coriolis
not
is not a
with the
real
Earth.
thing. Real thing. He's getting stuck making shit up, bro.
No,
Stop
it means
listening to him right now.
you've gone fully independent from Earth's spin.
Yeah, Jeremy, I can tell you that I'm not making shit up, and I would bet thousands of dollars that most Globers, and I'm going to say most, not all, because of course someone might disagree, but most Globers will agree with me. I would bet money on that. I am not making shit up.
I understand enough to agree. You're probably right.
Yeah, and from what I've heard you say
You're
just now,
telling me-
Don, you definitely seem to understand. Yeah.
Now you're telling me before you said the ISS had no Coriolis. Now you're telling me it's maxed out on Coriolis.
Yep.
Coriolis now.
That's the magic of reference frames, Jeremy.
Reference frames aren't magical.
Different ways
They're
of
not
looking
magical.
at
If you're making shit up on the spot and you don't understand reference frames, they may seem magical. I understand that.
I really didn't think you would. I'm getting more respect for you. I thought you weren't as knowledgeable as you seem to be. So I got to give you props for that.
Well, I'm playing devil's advocate. So I've been saying lots of weird stuff. I've been agreeing to feminism. I've been but basically, I'm saying I'm not saying it's definitely true, and I definitely understand it as a fact. Orbital mechanics, yes. I'm saying it works as a theory and a model, even to a layman, if they're trying to conceptualize spheres falling around spheres with gravity existing, and an ISS, so a craft blasted into an orbit.
it doesn't actually make sense. Just
You
like
blast it up there with a rocket, and
it's
then
just
you
like the
disconnect it,
explanations
and it
of how
falls around Earth
Superman
forever.
flies and
It's
everything.
quite
Yeah,
mental,
you
but
have
I do
explanation,
believe
but
it.
it doesn't make sense. The same shit.
But I guess where we differ, Gummy, is I don't think there's loads of nerdy astronauts on board the ISS doing those.
That's fine.
experiments.
You at least seem to understand the concept I was bringing forward on a like a
We were actually talking about it earlier, how
level.
the atmosphere goes round with the Earth. I imagine it.
Don, why don't you explain, if you understand it so well, why don't you explain to us how at one point ISS had 0 Coriolis, but now it's maxed out on Coriolis and has a lot of Coriolis?
Well, one way of looking at it is it's got no Coriolis. Yeah, so it's independent from Earth's spin. It's doing its own circle around Earth.
Yeah, that would mean Earth's not rotating underneath the
No,
ISS.
Earth it does rotate underneath sometimes. I think you get drift. Don't you
Sometimes.
looking at the stream?
You heard that?
The Earth moves on
Rotates sometimes under the ISS, not all the time.
in different motions. You'll get drift, I'm sure. That's why you
Sometimes
see different
the
parts of
Earth
Earth, don't right?
Sometimes Earth is rotating under the ISS, sometimes it's not. Okay, now what?
And it's, if you think about it the other way, it's max Coriolis because it's found a completely independent spin that it carries on doing.
So when the Earth isn't,
I can't explain it past from a different reference frame.
Yeah, that's fine.
But
Let me just get
Don,
it
that's
straight.
essentially what you're doing. You're doing
when the
great.
Earth isn't rotating under. Let me just get it straight. When the Earth isn't rotating under the ISS, there's no Coriolis, right? Is that what you're saying?
Sorry, what was that question?
What happens when the Earth isn't rotating under the ISS? Is that when you get no Coriolis, when there's 0?
I'm one of these people that thinks if you're going in orbit or you're flying a plane really fast above Earth, yeah, or even in a helicopter, when you try and hold a place in space somehow, I think Earth drifts a little bit, but I don't think there's been many tests. I think it's just a flat Earth concept, wanting to see drift below something, and that's why I don't think there's been a full experiment or test. But I think it happens sometimes while things are in the air.
Yeah, what you're saying is actually what Glover's believe. Like a helicopter will like essentially not experience any pain to like angular conservation of angular momentum and all of that.
Go around
but
with
on the very technical sense, anytime it lifts, it'll have a minuscule change due to it.
I'm saying I believe the super helicopter designed especially to measure the Earth rotating under it, somehow it could lock its position by stars, right? And hover there and wait for Earth to rotate under it. I think that's possible. I just think nobody's going to do it just for flat Earth.
Yeah.
That's similar to orbital mechanics, where you set something up to fall round and round. It's not dependent on Earth anymore. You're not measuring it relative to Earth. It's doing its own thing. You can still measure it to Earth, but it's not related to the axis of Earth rotating anymore. So you could, if it's going around in a weird orbit that's off angle to the axis of Earth, north and south pole, sometimes it would be like Coriolis would go up and down, wouldn't it? If you tried to measure it like a nerd all the way around.
The things you're saying makes me think you don't know what Coriolis is.
No, I'm just expanding it, like to try and get you to see it in a different way, maybe.
Coriolis.
So if you set up the orbit,
Don, hold on, Gummy. What's Coriolis, Don?
You can Google it, the actual definition.
What do you think it is?
I think it's when something's spinning round and you try and measure something else that's off it, you can measure effects, deviation.
Sure, deviation from the different reference frames. Sure.
Yeah.
Then you think the ISS has none of that?
I think the way, depending on how you think of it, I think it would go up and down and be none or all.
Depending how
And
you think of it is a not is ridiculous phrase. I'm sorry, but
that's what a reference frame
can I
think of
means.
it
give
Though.
as Earth's
so
rotating, and like you guys always like to do this thing where you go, and it's in the context of this, or depends how you think about it. When it's not necessary at all.
so
Ways to
if
think
but
about
if we had
Coriolis other than the Earth.
so if the orbit was from north to south, so it would cross over the North Pole, then the South Pole, North Pole. So so it's essentially aligned in the same axis as the rotation. Wouldn't it, Don? Wouldn't you agree that then the Coriolis stays constant? Or actually,
Sorry, I
not
missed the beginning.
constant, but it would be constantly positive.
Well, once
Like
it's
it
in
wouldn't
orbit.
be. Yeah, so it's in orbit and it's going in the same direction as the axis. So it crosses over North Pole, then South Pole, North Pole, then South Pole.
I know what to go the equator.
Sorry, say that again.
Wouldn't it have to go around the equator to be same as the axis? No, sorry. Okay, your example, up and down, round, north, south.
Yeah.
Always constant.
Yeah.
Well, I'm thinking a flat earther would say, right, as it goes north, it's a little bit fast with the spin. We can measure a bit of Coriolis. And then as it goes down to the equator, it's more and more and more. And then as it goes back to the south, it's less and less and less. Right? Like shooting.
Okay, if you mean that way.
Yeah, that's how I meant. Obviously, I'm not very good at explaining it in words.
No, I get what you mean. Yeah. Yeah, there's no configuration where you get a constant Coriolis, so to speak, because it always depends on latitude. But what I'm saying is it is always I don't even know how to say it.
Each time round.
Exactly, yeah.
Yeah. So depending on what you're measuring it to and what the angle is, you're going to get different types of amount.
Exactly. Yeah. That's what my point was. And you seem to have done it perfectly, so that's...
If we try and think like a flat Earth, they're trying to measure it against the rotation of Earth. So they want to know, does Earth rotate under it? Does it match Earth rotation? The answer is it doesn't match Earth rotation, does it? So Earth must be rotating under it.
Yeah, correct.
And whether they call that Coriolis or not, I guess is up to them.
Exactly, yeah. But technically that would be Coriolis to us if you use it in that way. Or at least to most of us.
Constantly deviating.
Yeah.
Isn't it for 1 second not deviating? That doesn't count it then, does it?
Mm.
The thing that I get suspicious of, I believe we can send a rocket up, let go of this thing at the right height and control it to fall into this thing. Holding that falling, that just because nature likes to hold a fall perfectly. That's what I find hard to believe. Even though I see the moon doing it, I've only been alive for 4 years, you know what I mean? So I don't know if the moon constantly does that forever.
Honestly, I feel like falling forever creates a different mental image than it should be. To me, it would be more like it's being shot off to the side and it's connected to Earth with a tether of gravity. That's just letting it spin around.
Pulled round, ball and falling round.
Yeah. Because the same way that, for example, when you attach a ball to a string and you spin it around your hand. Sorry, say that again?
It's not like spinning a ball on a string. We're not putting force from the center, are we?
You are, because when you're spinning the ball on the string, you're constantly pulling from the center because the string is attached to your hand.
Well, I mean,
if you don't,
we're not making. I mean, the nature's not making the spin from the center of Earth. That's not why the moon orbits. But yeah, you're just saying it fell there. Then it's on a tether.
Well, yeah, like for example, say that. Okay, you know those like not sure if you know what I'm talking about here, but there's like a pole and then there's a ball attached to the pole, and then you like bounce the ball between two players.
I think I can see it. If it falls in and the tether then connects while it's falling in, and it's got a certain momentum,
Yeah,
then goes round and round and round on its own tether.
exactly. So that the falling part isn't really like, it's not that it's falling directly towards Earth. It's more like it's shooting past Earth, but because of the influence of the mass of Earth, it's as if there's a tether attached that makes it spin round and round and round and round. And there's nothing to slow it down, so it's going to keep doing that.
Yeah, I'm totally behind the mechanism to create patterns because heavy stuff collects. I'm happy with it. Makes sense.
Yeah. You don't have to go as far as to accept space-time curvature, because that's definitely the extreme end of it.
I think space-time curvature is more of a phenomenon than an actual thing. I don't know if that makes sense.
Yeah, yeah.
It's more how we're looking at it than describing the actual mechanism.
Yeah, because as far as I'd want any flat earther to agree with is that mass attracts mass. And that's all I want. You don't have to go any further than that, whether you call it space-time curvature or anything else. As long as you accept that fundamental part, then I'm good.
If you read the proper definition of Coriolis, it says fictitious force, doesn't it, in it?
Yeah.
But it's because that's a concept, it's a theory.
I
explain relative movement.
Yeah. It's really annoying that it's called a fictitious force, because I think that the perfect word for it is inertial force, which is kind of a word a lot of people, not a lot, but some people do use it. Like, it's even on the Wikipedia page that it's referred to as an inertial force as well. But I feel like that captures it way better than calling it fictitious.
I think it's a force. I think it's what was I going to say? Relative movement. Relative movement relative to rotation.
Yeah, but the thing is that anything that makes something seem like it's accelerating is almost by definition a force, because force causes acceleration. And so that's why we kind of would still call it a force, but we kind of put in the caveat that it's not a force caused by some sort of interaction. It's just a force, as in like an acceleration that happens because of a reference frame. And that's
what
why
does inertial mean as a word?
So inertial means that it's essentially, if it's inertial, it's not accelerating. So it's like a non-changing reference system.
So it's like apparent acceleration.
Wait,
relative acceleration.
It kind of, yeah. Can almost look at it that way, yeah.
Because if it means non-accelerating, it would be non-accelerating force, and your definition was the force is accelerating. Accelerating things is a force.
Yeah.
I think it's just a type of relative movement.
Yeah, but that's the thing, is you're correct on that. We just decided that we call that a force because anything that causes movement is a force. Right. And then we put in the caveat that it's not because of an interaction, it's just because of relative motion. It has to do with the fact that from one position or from one reference frame you're accelerating, from the other one you're not. So you are right, but it's also kind of like it is captured within the definition. It just isn't as apparent as it could be.
Yeah, I'm a layman, so I don't know what lingo is accepted and what all the words mean in the context.
Yeah. But essentially what you're saying is what I mean when I say inertial force. Is that word inertial means that one thing is accelerating differently to the other thing, and that's why we're getting acceleration. which is essentially, of course, the same as saying relative movement in a